Alrighty, folks, we are back. Oh my gosh, why am I so tired? Because I've been up since 6 a.m. We had run club this morning. We were supposed to, and then it actually rained on us. It rained us out, so it didn't happen. So I've been working on our deck for the last few hours for work. I integrated a bunch of fun new things. So super excited to show the guys. But I'm gonna take a little break, do a little bit of learning here. So let's dive back in with functional programming. So I covered what is functional programming yesterday, or depending on when you see this video, maybe this comes out a few days after that video, but it was yesterday when I recorded it. And we are diving into first-class functions in this chapter. So we have anonymous functions, we have first-class and higher order functions, we have mapping, filtering, reductions, reducings, I should say, and a few other things. So let's cover this. So anonymous functions have no name in Python. We call them lambda functions after lambda calculus. This function takes in a single argument x and returns the result of x plus 1. Now, these lambda functions, I do believe, are different from the EC2 lambda functions or the serverless lambda functions within that ecosystem, or maybe they are the same. It's just those are ones that are running on a server in AWS or some sort of cloud provider. So I suppose a lambda function is probably pretty important to understand. So functions are just values. We can assign the functions to a variable named add1 and call it like any other function. So here we have a lambda being described here, plus x plus 1, and we're just passing it a value. So x is assigned to 2 plus 1. Right? So complete the categorize file function. It takes in one single string argument file name and should return a string representing the category of the file. The categories are as follow. We have a text, we have a document, code, unknown. Now, lambda functions for me, guys, being honest, I've wrote a few of them. Thumbs up, thumbs up. I don't know if this will record on the video. I hope it does. I just got a little animation of the thumbs up, but I've actually struggled with lambda functions, right? With building them and understanding when to use them, why we use them when we're dealing with the serverless architecture. I still never fully grasped the concept to why we use them. So let's keep learning. So the last line of categorized file returns the result of calling the anonymous function getCategory. Create getCategory within categorized file by using a lambda expression. It should take in a single argument extension and return the string representing the category of the file. The extension is already parsed out of the file name and passed to getCategory. You just need to write the logic for determining the category inside getCategory. Tips. I used the built-in dictionary.get methods in a lambda function. So here we are. So we have age equals person.get, person not available. I use the rf or the rfind method to find the final dot in the file name. So I think that's just recursively find and then slicing the string here. So let's see. So here's where it's slicing the string at the finding the period here. So assignment, what do we need to do here again? So we need to complete the categorized file. It takes in a single argument, our file name, and should return a string representing it right here. So I guess I'm not really sure what we're supposed to be doing, I suppose, because it looks like it's already wrote out for us. So getCategory file name. Do we need to build the getCategory deal? Is that what I'm seeing? Add one. that would make sense. Okay, so we're going to steal this model real quick, and I'm going to do getCategory, boom, 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 file name. Okay, so lambda x equals x plus 1. Let's see what we need to do. So complete the categorized file function. It takes in a single file name argument, so we'll go ahead and pass this in, I suppose, and the file name, and should return a string representing the category of the file. The last line here returns the result of calling the anonymous function getCategory. Create a getCategory, so that's what we've done here. By using a lambda expression, it should take in a single argument extension. Okay, and returns, this is going to be the tricky part. So it returns a string representing the category of the file. Ay, que lissimo. So the extension is just already parsed with file name. Not sure. Let's try this. Fail, unknown, XYZ, expecting unknown, XYZ. It's getting this, expecting unknown. Interesting. So expecting text. So I see. We need to determine whether it's a text. So getCategory. So we are splitting the file right here. This is returning the text of the file. So if I say dot split, what would this do? unknown XYZ. Sweet. So I think we just need to take the first of the two. Is that what we're doing? Nice. Something like that, right? Expecting code, bot, no. Oh, I see. I need to define whether it's a document or. Now, how do I do that really quick? So we have code, so .py equals code. Docx would be a document. So .split, maybe I could take the last item of the file name. So I could actually say -1 here, which would be the last thing. So we could start defining these. So we have py, Python would be code, docx would be a document, txt would be obviously a text file. So, okay, if get category, right? Maybe we say equals .txt, return text, right? We could just start kind of writing some if and else statements here. If get category equals docx, we could go ahead and return document. And maybe there's a more slick way of doing this, I'm sure. And then we could say if get category equals py, go ahead and return the code. Say else return unknown. How about that, right? Now, I'm not sure if we're supposed to do all these functions here or all these if-else statements. Well, we passed one, which is awesome. Expecting document x. Why did that not go through? I'm not sure the parameters of a Lambda function. Like I said, they're not my strong suit. So doing my best here, guys. Doing my best here. Let me just run this one more time. So the actual right here. Let's go ahead and define this. So we have xyz, py, x, which is document. So why did this not work? Oh, unknown. So that's a pass here. .py should be code, right? Oh, you know what? I think I need to pass this whole deal in. So I'll say document type here. I think that's what I actually need to do. So I think that'll work. And then we'll just delete that. Boom, 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 boom. Pass. Nice. We did the deal. We did the deal. That's pretty cool. Lambda function. Lambda, let's see what they did for their solution. Ooh, look at that. Okay, so that's probably how we're actually supposed to do it. So get category, it's an object. Oh, I see. They definitely led us down the right path here initially. So let me see. So Lambda extension, get category. So it's key value of this, and this. So get the extension unknown. Suppose that makes a lot more sense. Alrighty, cool. Well, let's keep it moving. So first class and higher order functions. A programming language supports first class functions. When functions are treated like any other variable, that means functions can be passed as arguments to other functions, can be returned by other functions, and assigned to variables. So first class function, a function is treated like any other value. Higher order functions, a function that accepts another function as an argument returns as a value. So we could pass a function in as a value. So here's the function being passed in as square. That's cool. So the value itself is being passed in, right? Or that's a first class, excuse me. This is higher order example. So how does that work? So my map, which is returning square. Oh, cool. So what function returns another function? A higher order function. First class and higher. So which is the higher function in the second example? Let's see. Higher function, I believe, is going to be square. Let's see. Nope. My map. No, is that not? There it goes, folks. Okay, so that's the higher function. Okay, that makes sense because we're passing in kind of like a child deal. So that's the parent, I guess, of the two is how to think of it. So map, filter, reduce. These are three functions that are commonly used in functional programming. They're also the names of three of the most common higher order functions. In Python, the built-in map function takes a function and an iterable, in this case, a list. It returns a new list containing the result of the function for each item in the iterable. With map, we can operate on lists without using loops and nasty stateful variables. For example, here we have everything here. So we have squared map, squared nums, print list, squared nums. Markdown supports two different styles of bullet points. Okay, so we only want to use the asterisk, or the multiplication sign. So we need a function to convert any dash bullet points into star bullet points. Interesting. So this is a bullet. this is a bullet. So these are okay. I see. So that's just for the function. I was thinking for some reason that's like some Python syntax, but it's not so much. Okay, so let's see. Change the bullet style. So we need to do some functions, I believe, some higher order functions right here. Let's see what our document is first. So I'm going to print this, and let's see here. Let's go ahead and pass it here. So any questions? So don't edit below this line. So convert. Let's see. Change bullet style. So first we get the document, which I think the document is all of these things. Let me put here to here, or ear to ear, I suppose. So we can see which outline is the document. So it looks like right here. So anything with this. So let's maybe parse that out. So document map, we'll say items. Can you arrow function into things with a map here? I guess I wouldn't know how to use map within Python. So let me print it out, see if that'll work. Print, no arrow function. So how do they use it? Map, just like that. Okay, so map square nums. Interesting. So where's square? We have this. Okay, so we can go map, convert line, right? And maybe document. Wait a second. So we'll say changed, just to give it a variable. And maybe this will work. So the inputs, expecting what was the actual? None. Interesting. So old bullet equals this, new bullet equals this. If length of line is this, what if we give it the first deal? No. Okay. What the heck? Okay, let me see the solution. Return, boom, join the split of the document at the new line space. Guys, I slept terrible last night. I feel like that's one of those horrible things with programming. You like need good sleep because like my brain is just not, you got to be so keenly aware of all the details and all the fun stuff. So I'm just chugging coffee like crazy right now. Wish I could sleep for like 6 more hours. But I was up and ready. 5:45. I was ready to go. It was just pouring outside, and it's a good old time. Okay, so filter. The built-in filter function takes a function and an iterable, in this case a list, and returns a new iterable that contains only the elements from the original iterable where the result of the function on that item returned true. Okay, so we have list, filter is even numbers. Ooh, fun. Okay, so we can do some fun stuff. So here's the assignment. So complete the remove invalid lines function. It scans the document, removes any lines that start with the old bullet points, preserve any new line characters from the original document, including the new line at the end. Interesting. Okay, so we can try, let me see. So if I say filter, what do I want to do here? We want to split. We want to remove any lines from this document, right? So document dot split, something like that, I think, from the document. And I can try to return that. Try filter. Try this. Boom. List. No. Let's see. So functional programming is not my deal. This is why I'm running through this course especially. It's just to help fill in these gaps that I'm not fully good with. Okay, so basically we want to remove any of these old lines, right? So document.split. I imagine something like this. That'll work. So actual output. So this is the print statement, I believe, right? Let's just put a bunch of stars right next to it so we can easily define it. Oh, I don't see it actually. Oh, right here. Boom. Okay, so the plan. So this is the expected output. So great. So phase 1, we want to remove that, I think. So we have the plan. We want that. And then remove this. And then we want this, right? Any questions? Same with the profit. What do we want to do there? What if we split all the new lines where we at? Cool. Okay. So that'll work. And then even split this. What would that be? Would that be everything? I don't know if you can do that. Okay. So this is the lines we want. We want the plan, we want phase one, and then we want any questions. So this is our list splitted. Let's see. So I could say list. Actually, I don't even need to say list. Just say new line split, boom, document split. Okay. So that's that. And then can I split again, or we already tried that pretty much fundamentally? I think we did, yeah. So I think I need to then map this through or do this new deal, which is the filter. So let me try this. So filter split, and I will split the new line. Now, I'm not sure what I need to do here. Do I need to build a new function that removes the line itself? I'm going to try that. I'm going to try to do that. So let's build a function that says define remove line again, I suppose. And this will take in document, doc, and it's getting a little recursive on us. And this will say doc.split, and then I'll try that, right? So will that work? Actual output, none. No, okay, that's not what we want to do. Trying to think. So basically we split the lines here, right? And I suppose I want to filter through this, right? So filter anything that begins with this. Just I'm not sure how to work these filters with this. Okay, so I'm gonna peek at the solution. Let's see. So filter more lambdas. Okay. So return new line join filter lambda starts with the document split. I folks. Okay, let's see. Let's read, let's learn. So what's going on here? So we have a filter with a lambda line, not line starts with. Okay, so this is kind of like the mapping, I suppose. So I'm very used to JavaScript syntax. So if we had a list that was like, here's a list of strings, right? Strings of numbers. So we'd have const list. We'd say maybe even numbers would be a better example. So I could say numbers.map number, and then I can arrow function into it and do what I want to do here. So like I could say number includes like a dash, right? So I'd have to split it, I think, initially to actually make this work, but see which ones would have the dash in front of it. So I think that would return it. I could filter, right? So I could do stuff like that as well. But this lambda function stuff, it just hurts my brain. Like I'm staring at it. It's still just not like I don't know. I guess this is kind of this bit right here. This line is kind of this bit, and this is like the arrow function, I suppose. So it's like arrow function, you had to do something, but then this is what you feed it. So instead of saying numbers.map, it would just go, I suppose, over here. It's how to look at it. So let's say lambda number. Just okay. I think that makes a little more sense in my brain. Okay. So what's the new line deal? So return new line join, right? What does all this mean then? So anything that starts with this and split by the new line. So let's try it one more time. So filter, I'm going to start with this. I just want to see each bit of it. So filter the document. I'm already stuck. I'm already stuck, folks. So do I say document here, or this was where the lambda goes? Lambda line. We want to say not starts with. Do I say document here? Document dot starts with, or line dot starts with. Okay, I think this is on the right path, right? Nice. Okay. Actual output. No. Oh, that's actually not then. Okay, so not starts with this. I don't understand the lambdas, folks. I don't understand them. I don't understand them. So lambda line. So we say line dot starts with. Let's just see. And then we pass in the document. Will this just give us a list of documents? What if we map it? Okay, let's see the actual deal one more time. So return join. Okay, so return lambda boom 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 document split. But can I not just print this statement and see what it says? Let's see. I can. It's just actual outputs none. Okay. Well, let's move on, I suppose. Let's move on. Let's see what we got. Okay, so we have reduce and accumulate. Okay, so accumulators, fun. Oh, I remember learning reduce in JavaScript, and I was nasty with it when I actually first did. So in JavaScript, again, just for sake of my brain, right? You'd have a list of numbers, so we could say const numbers equals this. So we could say numbers dot reduce, and then I'd have my accumulator. That's it. A plus B start at 0. And that would reduce the entire function. That would just surmise everything in that array. Now, I have no idea how to do this in Python. So let's learn. So it looks like I take functools, import functools as a standard library, and we use reduce from there. Then I need to declare what function it is here. So we have add, and then looks like the numbers gets passed in here instead. So that would be roughly the equivalent, I guess, I suppose. I need to build the add function. Okay, let's go for it. So the assignment, complete the accumulate and the accumulate first sentences functions. This is a helper function used by functools.reduce and the accumulate sentences deal. Its inputs are doc, a string representing the growing document, and sentence, the next string to be added to the document. It returns a new string representing the updated document. Sweet. Okay, so this function takes a list of sentences. Let's see. I just want to see the output. So boom, accumulate first sentences. So accumulate is a helper function in the accumulate. Okay. Its inputs are doc and sentence. It returns a new string representing the updated document. So is it just return doc plus sentence? Is that what I understand here? Puts our boom, boom, boom. Note, it joins the sentence into the document with a period and a space in between. So, period and a space in between. I think that's what it wants. Or these flipped, right? Either or. Tomato, tomato. Relatively close, right? Resulting in correct punctuation. Oh, that would make sense. So, sentence.document. Okay, so let's see. Now the second bit, so this accumulate first sentence, it takes the function, takes a list of sentences and the number of sentences to truncate to as input and returns a single string output. The return string should be the first n sentences of each line in the document, concatenated together with a period at the end. Okay, so hello there, kid. It returns that. Okay, so if I get a sentence, so it takes the sentences for sentence in sentences is what I'm thinking, right? Or so n is the length of how far we want to go, like the range of it, right? So for sentences, so maybe we could even just say 0 to n, basically, right? Would that work? For sentence and sentences, return sentence. And I know it's now why is that not gonna work? Okay, so sentences should be a list. Now I know it wants to reduce it. It wants us to say functools reduce, but that's roughly how I see it as what we're doing, right? Something like that. It's roughly the format that I see in my brain, I suppose. So let's do functools that reduce, and we'll say accumulate and sentences. How about that? And we'll return that. So inputs actual, boom, hello world. Let's see. So we have accumulate. I'm going to flip these real quick. Hello world. Great. So we're getting there. We just need to do now the number of n. So slice. Would it not be 0 to n? Is that not a thing? Can we not just do that? Or range like that. Would that work? No. It's kind of fun. Okay, so let's see. Sentences. What about that? Almost there. Hello world, we're almost there, almost there, almost there. I guess technically I could do that. Just be a little bit cheeky about it, right? Right? Maybe that'll pass. Almost, not quite. It says we got a few passes. Interesting. Interesting. Okay, let's see what they did real quick. So we have if not sentences, or I see. So if the sentences, sweet, they did get the same logic. So they just did a guard clause. If sentences, so if there are no sentences, so if length of sentences is less than 1, return this. And then I suppose you could do in as well, or no in, basically, not in, or in less than 1. Sweet. Cool. So which is imperative way to apply changes of a list of item? I'm going to say function. It wasn't. It was a loop. It was a loop. It was a loop the whole time. Okay, let's see. What's the primary advantage of composing functions instead of loops? Avoiding stateful mutations. Let's try that. Let's try that. That's probably about right. Okay, let's see. Oh, we're on the challenges already. Sweet. Well, that was quick. Felt quick. So the intersection method calculates the intersection between two sets. An intersection of two sets is a new set that contains all the elements that are in both the original sets. So we have 3 and 4. We have 3 and 4 in both of these sets, or dictionaries, if you will. But a set is basically a dictionary with no repeating items. So complete the get common formats using the intersection method. So we can do something like a dot action B. So let's try this. Intersection formats 2 and return that. Let's try. Interesting. So that just off rip doesn't work. What do you mean? What is the difference here? Did I spell that wrong? No. Okay, so let's print formats 1. Let's see what's actually in the formats. So it looks like all these lists. So they're a list, and we need to make them a dictionary. So how do you make it a set? Is it just you wrap it with set? Is that it? Just like that? Okay, cool. Well, that was easy peasy. And let's say this dot intersection, we'll say formats 2 and set here. And I think I just need a closing parenthesis. Let's see. Cool. So we're printing everything, but I'm actually not seeing the intersection, or are we? Return. Let's try. Run, pass, sweet. We are getting the intersection. Cool. Alrighty. So that we had to take the lists into sets and then check for that intersection. Cool. Seems straightforward. So that was our 2 sets originally. There's a few overlapping documents, specifically the text, PDF, and HTML files, and we got there. Super fun. The zip function takes 2 iterables. In the case, I think this is our last one too, guys. So the zip function takes 2 iterables, in this case lists, and returns a new iterable where each element is a tuple containing 1 element from each of the original iterables. What does that mean? So 1, 4, 2, 5. Okay, I see. It kind of zips them together, a little zipper or something. That's cool. So it looks we're going to do that with our document names and our document formats. So let's try this and let's print them. So we have our doc names, presentation summary, so PPTX, PowerPoint, and then a document. So we are obviously going to say, here's our list, right? I'm just looking at the format on the left here. So we have our list, and then we'll actually wrap it in a list. So this will actually be, maybe I'll say correct formats. And we will zip together the doc names with the doc formats. I think that's it. And we just print that, and that might be all she wrote for the day, folks. That might be all she wrote for the day. Let me return it. Not sure if we need to loop it or something, but passed a few, failed a few. Okay. Oh, maybe we have to check if there's any invalid things. Okay, so check if the correct formats are given. Got it. So we're almost there. We just need to do some data checks real quick. So it looks like some of them have documents and some of them maybe don't. So I'm just going to see the data real quick. So we have the names and the formats. So name, summary, boom, boom, boom. So that works for that one. But what about this where we have 1, 2, 3, 1, 2, 3? Oh, that should still work, right? Why is it not working? Next, filter the list of tuples to only include tuples where the format is one of the given valid formats. I see. So we need to validate the formats. So correct. I should say not formats, but document zipped. And then this will need to be filtered. So filtered, which I'm not totally sure on if we need to build another function. So filter valid formats, and this will be filtered list or filtered tuples. Perhaps that's all we needed. Nope. Wish it was that easy, right? Wish it was that easy. So valid formats. I'm not sure how to filter it. So let me peek at the solution. So return list. Of course, it's a lambda function. So we have a filter lambda x. So that's okay. That's the second part of the tuple. So x1 invalid formats. Interesting. Zipped document. All right, I'll close it out. Try my best to do it from memory. So we have the document zipped, and then I need to. Oh, I'm so bad with these lambda functions. I already forgot. I already forgot. I know we just looked at it. So filter. Let's see. So we want to say, is it lambda x? And then we can say x1 document zipped. Wait. We need to say invalid formats for the document zipped, right? Let's try. Sweet. Did we get her done? No way. That's pretty cool. I'm still not totally certain on the lambda functions. I think they're just arrow functions. They seem to be that. But where I get a little dicey is the lambda functions in the serverless environment. I think that completely different beast. But yeah, so that's a bit more on first-class functions, guys. And then we're going to learn about pure functions here shortly, which are very, very useful and usable. And we will continue down the journey of learning more programming stuff. Pretty stoked. Pretty stoked. Because Python is it's it, you know. So this will be fun to get into stacks, queues, heaps, and trees, hash maps, tries, graphs, all that stuff. Breadth first search, depth first search. It's gonna be a good time, you know. And then I feel like from there we're getting out of the data structure and the algorithm part. We're gonna kind of go to the servers. It looks like, which is going to be building some servers with JavaScript, and then Golang, of course, and then kind of data handling and aggregating bigger things, I suppose. So it should be a good time. We're just kind of chugging right away and just clicking off one thing at a time, guys. Thank you so much for watching the series, and I will see you on the next one.